Assalamualaikum. Today I want to present my research finding entitled Assessing the Educational Impact of Smart Thinking and Industrial Problem Solving Stimulator on Analytical, Creative and Practical Thinking among TVET students. So for this presentation, I will cover introduction, literature review, methodology, finding, discussion, and also conclusion. Introduction. Higher order thinking skill, HOTS, abilities are essential component of teaching and learning in technical and vocational education and training, TVET. This study aimed to evaluate the effectiveness of the smart thinking and industrial problem solving stimulator, a learning tool that incorporates simulation of 18 industrial cases designed to access analytical, creative, and practical thinking skill. Each case scenario was structured according to three constructs: verbal, quantitative, and figural. The verbal cases emphasize text-based problem context. Quantitative cases required mathematical reasoning and logical analysis, while figural cases utilize chart, diagram, table, and symbol to support visual problem solving. The issues. Research finding in the field of TVET on technical education students in Malaysia show that the level of high level thinking skill HOT, consisting of element of decision making, problem solving, error analysis, and classification are at a low level. This is according to Hyong et al. 2011, Hamdan et al. 2004. Skills such as investigation, experimental inquiry, comparing differences, deduction, and justifying are at a moderate level. Hong et al. 2011 and Hamdan et al. 2004. Hong et al. Found that technical students do better in practical thinking skill more than in analytical and creative thinking skill. A study reported by Chinadu et al. 2015 analyzed 300 engineering and science students, found the level of HOT to be low and requires specific strategies in TVET to meet industry challenges. Literature review. The study conducted among 149 engineering students support the case-based teaching method. The findings show that case-based simulation is able to provide a more dynamic, interactive, student-centered learning environment and encourage the active involvement of the VET student in learning. Lopez et al. 2000-2003. A study by Lavie and Marty 2000-2003 on the problem of strengthening critical and creative thinking skill among engineering students at universities has also found that the case-based simulation pedagogical framework is advantageous because it is a contextual learning of discipline or practice-specific knowledge. The finding of Obagi and Muhammad 2000-2005, we show that case-based simulation is significantly a factor that affects respondent scores in analytical, evaluation, and deductive reasoning. So this is a research question for this paper. The research question is there a significant difference between the post-test score of analytical, creative, and practical thinking skill among technical school students for the control group, treatment group 1, and treatment group 2 by controlling for the pretest. Methodology. For this section, I will cover research design, sampling design, instrument and test analysis, and also data collection procedure. Quasi-experimental research design is applied using quantitative data collection, sampling design using convenient intact group sampling design for this study. The total of 60 technical students were assigned by class and placed in a control group n equal to 20, treatment group 1 n equal to 20, and treatment group 2 n equal to 20. Instrument used is Standard Tragic Abilities Test STAT to collect the data. The reliability for the STAT is as follows: 0.74 for analytical thinking, 0.83 for creative thinking, and 0.79 for practical thinking. The Markova test was used to obtain pre-test and post-test differential score for the control and treatment group. This statistical method tested all the study hypotheses. For the data collection procedure, the treatment group went through the learning process using the interactive application, smart thinking, and industrial problem solving simulator, which is experiment 1, self-directed app learning group, and experiment 2, collaborative learning group. The other 20 students acted as a control group who went through the learning process as usual without being exposed to the use of the application. Finding. The result in table 4.3 show that there was a significant group effect on all three variables relied on in the study, namely post-test analytical thinking skill, practical thinking skill, and creative thinking skill. The R2 values under table 4.3 show that the independent variable group of this study accounted for a 30% change in the dependent variable of the analytical thinking skill post-test, 49.7% change in the dependent variable of the practical thinking skill post-test, and 50.8% change in the dependent variable of the creative thinking skill post-test. This is the finding for line graph analysis. The blue line graph shows the analytical thinking skill post-test of treatment 2, which is collaborative app learning group, outperforming treatment group 1, which is a self-directed app learning group and control group. The red line graph for the practical thinking skill post-test show that the score of treatment group 1 self-directed app learning group outperform treatment group 2, which is collaborative app learning group and the control group. The green line graph for the creative thinking skill post-test also show a high increase in score for treatment group 2, which is collaborative app learning group, compared to the treatment group 1, which is a self-directed app learning group and control group. The discussion. The Markova analysis of the use of smart thinking and industrial problem solving stimulator among technical secondary school students score better if they thought analytically and creatively through case-based simulation in collaborative app learning group compared to self-directed app learning group. Practical thinking skill through self-directed app learning group are better than in collaborative app learning group. Conclusion: notably, smart thinking and industrial problem solving stimulator in collaborative app learning group contributed to a better score increase in the analytical and creative thinking skill post test. While the use of smart thinking and industrial problem solving stimulator, which is a self directed app learning group, contributed to a better score increase in the practical thinking skill post test compared to the collaborative app learning group and control group. This is my conclude presentation. Thank you for listening.